Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hakim bin Muhammad Faizal. I'm from group number 9, and today our group will present about triangular wave oscillator. But first of all, our group consists of 4 people, which are Muhammad Al-Mizan bin Muhammad Arif, Song Kayun, Luqman Haziq bin Sahalani, and lastly Muhammad Hakim bin Muhammad Faizal.
Okay, the first one is introduction of triangular wave oscillator. A periodic non-sinusoidal waveform having a triangle shape is thought as a triangle wave. The difference between triangle and sawtooth wave is usually misunderstood. A triangle wave primary distinguishing trait is that its rise and fall times are equal, whereas a triangular wave rise and fall times are unequal. The OM integrator may be used for the basis triangular wave oscillator. The basic idea is illustrated below, where a dual polarity switch input is used. We use the switch only to introduce the concept. It is not particular method to implement the circuit. When the switch is in position 1, the negative voltage applied and also the output is positive going ramp. When the switch is thrown into position 2, a negative going ramp is produced. If the switch is thrown back a fourth at fixed interval, the output is triangular wave consisting of alternating positive going and negative going ramps as shown within the diagram below. An input wave is required to generate triangle wave. Square wave are used as input in this project. Both square wave and triangle wave have equal rise and fall times, making them easier to convert to a triangle waveform.
My name is Song Kayun and I want to present about the block diagram of oscillator. When a DC supply provided to the amplifier will convert the DC voltage into a AC power. The AC signal will given to the oscillatory circuit through a positive feedback network. Further, the oscillations from the oscillatory circuit are fed to the amplifier. At last, at the output of the amplifier, amplified oscillations are achieved. Next is the operation of the circuit. Triangular waves are the triangular shape, periodic and non-sinusoidal waveform. It has symmetrical rise and fall time. Some sort of semiconductor device like op-amp and capacitor are needed to form a triangular wave oscillator. It will charge and discharge continuously to produce cyclic waveform. Square waves are needed as the input to produce triangular waves. It is because square waves has equal rise and fall time. It is easier to convert into a triangular waves. So a basic triangular wave oscillator are divided into two parts, comparator and integrator. At startup, assume output voltage of comparator at a maximum negative level. The output then is connected to the inverting input of integrator through the R1. A positive going ramp produced at the output of integrator.
Okay, so now I will continue the operation of the circuit from Song Kayun. So as we know, when the ramp voltage reaches the UTP, which is upper trigger point, the comparator switches to its maximum positive level. This positive level causes the integrator ramp to vary to a negative going direction. The ramp continues during this direction until the LTP, which is lower trigger point of the comparator, is reached. At this point, the comparator output switches back to the utmost negative level and the cycle repeats. This action is explained by the waveforms on the picture.
So, for the important formula, as we all know, the output amplitude of the square wave is adjusted by the output swing of the comparator, and therefore the resistor R2 and R3 set the amplitude of the triangular output by establishing the upper trigger point, which is UTP, and lower trigger point, which is LTP. So for the first formula, we have VUTP equal to positive Vmax times with R3 over R2, and the second formula is VLTP equal to negative Vmax times with R3 over R2. We also know that the comparator output level, positive Vmax and negative Vmax are equal. So the frequency of both waveform depends on the R1 times C. So the formula for frequency is Fr equal to 1 over 4 R1 C times with R2 over R3. So by varying the R1, the frequency can be adjusted without changing the output amplitude.
Okay, so now I will explain about the application of the oscillator. Triangular wave oscillator can be used for sampling circuits, thyristor firing circuits, SCR circuits, frequency generator circuits, and tone generator circuits. For example, like the second picture, which is sample and hold circuits. In electronics, sample and hold circuits is an analog device that samples, like captures or takes the voltage of a continuously varying analog signal and holds. It locks its value at a constant level for a specified minimum period of time. Sample and hold circuits are related. Peak detectors are the elementary analog memory devices. They are typically used in analog to digital converters to eliminate varieties in input signal that can disturb the conversion process. These sample and hold circuits are also used in electronic music, for instance, to impart a random quality to successively played notes. Okay, so that's all from us, Group 9. Thank you.